So I found a new tool that helps us diagnose this type of issue where you cannot activate a phone because of a baseband issue. This one specifically is an iPhone 7 A1660. Super common problem on these, and we're going to use this new tool that I found called iCommand Stylo. Lets you use purple mode on this device so you can read the voltages through the computer instead of actually measuring them with your multimeter, which is super convenient. Also has a ton of other diagnostic and useful information. So today's video, we're going to walk through how to use it to diagnose this phone. We're actually going to go through the process of repairing this device and everything around that. So hi, I'm Jesse from VCC Board Repairers. Thanks a lot for joining us here on the channel. If you like these type of videos where I show you cool tools that I find online, smash the like button, subscribe to the channel to see more videos like this, and share this video with all your friends. Also, don't forget down below, I will link to this specific software, all my tools for soldering, and everything you see in this video down below, as well as this t-shirt, Keep Calm and Fix Phones. So if you do phone repairs, you should pick one up. So let's go ahead and get started with this video. So first, let's go over the issue at hand. This is an iPhone 7 that does not activate. You can see up here it says no service. If you unlock it and turn it back on, push I, no IMEI. So it definitely has a baseband issue. So to fix this, we're going to use several tools, only because my computer doesn't work with this iRepair P10. So usually I would use this by itself, but for some reason this software for my specific PC doesn't work. Anytime I need to use this, I have a separate laptop that I plug into temporarily just for this. But the tool that we're going to use does not work with this one, so I'm going to use a combination of both just so we can get the end result of putting the device into purple mode first, and then using this tool to plug into the other tool. So this is the JCP13. This is a NAND programmer for iPhone 8 and newer, for like the NAND, physical NAND to pop in here. But it also has a special cable here that you plug into the phone for purple mode, which is a special diagnostic mode that Apple uses internally, and somehow people figured out how to give us access to it. So first step is, let's get the device into purple mode. So what that means is basically I'm gonna unplug it from the PC. I'm gonna plug in the phone to this. So this is plugged in through USB-C to my computer. This is plugged into the phone through the lightning cable. And then I have the JC Repair Assistant software, and we're gonna connect to it. So you can see here P13 is detected, click connect. And then the software is not connected to the P13. We need to put the device into DFU mode. So iPhone 7 specifically, these are the steps you got to follow. So you press and hold volume down and power for 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let go of power. Keep holding volume down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you'll see here, screen is black, but the tool here says purple screen. It's ready to go. So I'm gonna click it. That's gonna do its thing so that the phone goes into purple mode. So just wait it out. You see the tool is doing something. You see the green text, which is basically a log of what it's doing in real time. Just wait it out. And it's called purple mode because you get a weird colored screen. It might be purple, it might be some other color. Right now it actually is kind of like a blue, dark blue, purplish. But you see here on JC Repair Assistant, it is in purple mode. So now that we got the device in purple mode, I can unplug this and actually unplug this. We no longer need this, and get this out of the way. We're going to use the iRepair P10. So from my PC, a lightning cable plugs into the P10. The P10 plugs into the phone using their little special cable. Plug that in, We don't need the JC software. Okay, so I've opened up the iCommands Stylo software. You can download it at iCommands.com.br. So there is by default in Portuguese because it is a Brazilian team who made this, or guy. I don't know who actually made this. I think I see them posting in the groups and stuff. But make sure you always select the USA flag for English. Essentially, once you have the P10 plugged in to the phone in purple mode, you'll see there's a COM port selected here, and you see there's a model box. There's a bunch of different tools that lets you pick which DFU box or purple box or whatever. And I believe it used to give a pop-up. I don't know what happened. Usually you get a pop-up saying if these models is the purple mode tool, select one. If it's the other one, use the number 2. I don't know why it's not. Oh, you know what? It's right here, I think. Yeah, so pick model box 1 if you have the P10 and these other ones. So I have the P10. It has detected on COM5. And this tool is free for iPhone 7. For any other model, you do have to pay, I think it's $55 per year, which is pretty cheap if you're able to use this to repair devices. So let's go ahead and click connect. And it's, let's see. If you are testing iPhone 7, repeat the process without disconnecting from the box. All right, there it goes. So I just had to click it twice. You can see here it detected A1660. So now that I'm connected, there's like a million things up here in the menu. Specifically, we're trying to test for baseband. So that would be under RF. And if you click RF, you can click all these different wireless technologies that are in the phone. So baseband is basically the cellular. So you click on, and it's running special commands to the motherboard to get some information from it. And you can see here, you got a response saying error, PS hold never went high after 500 milliseconds. So basically it said it tried to do something and it didn't do what it's supposed to. It didn't go high after 500 milliseconds. So there's an error. Now for comparison, let's turn on Bluetooth, and Bluetooth turned on okay. Turn on Wi-Fi, and I guess Wi-Fi on success. Turn on GPS, good. NFC, good. So you can see how all these other functions work, meaning, this device is in an engineering mode. This is a, programming mode for the Apple engineers to mess with it through the PC rather than having to use multimeters and, the old-fashioned way. They have built-in diagnostics into the device that is meant for internal use, but these guys figured it out, all the different commands to do that. So turn on baseband again, and oh look, now it worked. So this is kind of how you can use this to try to diagnose baseband issues. If you're able to turn it on and off, then that usually means baseband is working. So if I were to restore it right now as it is, it might actually restore and activate properly. But because it's kind of, for me, I've actually was using this yesterday. I wasn't able to turn on baseband until like a bunch of tries. So this is one way you can do it. You can see I'm able to turn it on and off. Let's see what properties does. So I give you some information. So type baseband powered yes. So it means it's on. Let's turn it off. Also down here, RF voltage. So this is just for reference, so you can see that, what to check for. If you're using an Intel model, check these lines for these voltages. Now, when you're measuring voltage, this is something you do while you power on the device. So that's where it kind of gets tricky when you're measuring voltages. If you have a Qualcomm model, these are the different voltages you should check for. So that's useful. Comparator. Okay, this is just what a known good result should be. Oh, look at that. See, now it stopped working. PS hold never went high. Try again. And now it did. So yeah, it seems to be some unstable kind of connection to baseband. Let's see, we can also go to PMU. So if you want to get the, let's see, PMU is basically PMIC. Click buck, and you get all the buck voltages from the motherboard. You can see you read 0.576 volts, how many milliamps, and this is the reference voltage. This is what it should be. This is what we got, is within this tolerance, 0.23%. So these are all good voltages. Same for the LDOs. You know, the logic board does have, you know, all these different power lines. So this is how you can use this to diagnose issues. So let's say you have an iPhone 7 that doesn't turn on, or is like it's boot looping or something, but you're able to get into purple mode. You can use this to check the voltages of everything without even, you know, taking it apart, basically. So you can use this for this. Let's see. I remember there was another part. I2C lines. So there's basically 5 I2C lines, 0, 1, 2, and 3, and then AOP. So you got all of them came back as good. For I2C1, it's good. I2C2, I2C3. I2C3 is display EEPROM, no communication. Display disconnected from the board. Let's try to read it again. Yeah, it keeps giving an error, so I don't know what that means. I do have the display connected, so it's a replacement, so maybe that's why it's detecting that the original is not there. But for iPhone 7, that doesn't really matter. The prox works fine. Auto test, I don't know what that does. Oh, look at that. So it tests all the I2C lines for you. So this is also very useful for any kind of boot looping, no power type of scenario. Look, even it comes with PDF files. So if you want to kind of dive deep on this. Oh, let me see. Let me zoom out. Look at that, even block diagrams. This is amazing. So this is the CPU, and then I believe the CPU, yeah, and then all the different connections for everything. Let's see, what else do we have? Battery information. So yeah, basically kind of like 3U tools where you get some battery information. Tigris, Tristar. So look at that, you can read the voltages going into Tristar. So PP3VO, PP1V8, SD RAM, PP ACC So I believe this one is if you have like an accessory plugged in or something. Tristar data. So you can even query the data lines for Tristar. Tristar communication. It's able to talk to Tristar, I guess. And Tigris power supply. So VDD main comes in. Here comes the USB charging from the USB cable. It's 4.75 volts, and out goes to the battery, 3.55 volts. So imagine how useful this could be if you're trying to diagnose different issues related to the different problems here. Let's see if we go, I think. Yeah, so this is kind of the same thing as the last one. It has, not the last one, but the buck lines. LDOs, V-Core. Yeah, so I'm definitely gonna buy this, especially once I get a device, especially for like data recovery. This will come in handy real fast. Now there's also the command section here. This is where it just gives you a bunch of commands here. I think what this does is it actually gives you the commands you need for if you want to manually send it yourself. Or you could select the command here, on, submit. It sends a command to the device and it's saying it's already powered on. So let's turn off baseband, submit, and it's done. And now we can turn it back on, submit, and turned on. So this is more rudimentary, but just sending the manual commands. I remember I saw something else. Let's see, where is... All right, so yeah, you kind of get the rough idea. So I definitely recommend you guys check out this tool. So in my case, I do know this iPhone 7 has super common issue with the Baseband PMU. This is a power chip for baseband where the ground pad is weak or broken. So if it's sometimes touching, then the circuit functions fine. If it's not touching, you'll have issues. So that kind of explains why sometimes you're able to turn on baseband. Like right there, turned on. Let's turn it off. Let's turn it on. And it failed. So that could indicate a weak connection for that baseband PMU. But also, baseband CPU is super common to need a reball, which would kind of give you the same symptoms where sometimes it works, sometimes it doesn't. Although that usually happens after an audio IC repair attempt. So someone tried an audio IC, used too much heat, and baseband disconnected because it's directly on the other side. But this one does not have any audio IC work done in the past. So this leans me towards being baseband PMU. So look at that. Turn on and turn off. So it works. Doesn't. Well, turn it off, turn it on. So yeah, and then just having like this type of information tells you which component to measure at. Super useful. So let's go ahead and try my theory of maybe baseband PMU with the weak ground pads. All right, so here in the back is a Qualcomm PMD 9645. This is the baseband PMU. This is what powers the baseband circuit, the cellular circuit. And what I'm gonna do is I'm gonna remove it by adding flux. And then I'm going to use 400 Celsius 80 air. And I'm just going to heat up in circles. Now I am on a preheater set to 120 Celsius. And it should come off any second now. There it goes. And actually, I like to just replace it because might as well. And this is the ground pad I was talking about where it's like weak. Yeah, see, it's broken off. One thing you'll notice is, well, first let me prep these pads this while we're here before I forget. And I did bump this crystal here at the bottom, which is fine. Alright, so I'm going to use my micro pencil knife tip here to try to prep these pads. I'll feed some solder. What I like about this soldering iron tip is how I could kind of use it flat to provide more heat, or use just the tip of the iron to kind of do any accurate or what do you call it? If I just need a, something pointy so I could hit a specific spot. All right, so I've prepped all the pads. I do see one pad looks a little burnt. So anytime you get a little brown on a pad like this, make sure you clean it up, otherwise you won't be able to solder onto it. All right, so this is what I was saying is this ground pad. So these pads aren't connected to ground other than these two are connected together, but the only way they're connected to ground is through this area right here. And what happens is, kind of like audio IC, the pad breaks, and these are now no longer grounded, they're just floating. And that causes problems because within the circuit, it needs those ground pads. So the solution here is to reinforce them by adding a jumper. So what I'm going to do is, well here, let me show you. So my multimeter, I am set to diode mode, and so for example, this cap right here gives me 256. This is ground. This pad, OL, this should be ground. These are ground. So these are OL. And that's that push down, and it kind of makes contact again. So yeah, you can see how, my guess is because this is kind of loose, sometimes it connects, sometimes it doesn't, causing when I query the baseband to turn on and off, it sometimes doesn't respond because it has lost its ground connection, causing problems. Eventually, what can happen is baseband gets shorted internally, and the idea is due to the lack of this ground, there's like surge in voltages going to the baseband itself and killing the chip itself. So if you have a baseband that gets fully shorted, then you're basically SOL. If you don't know what that means, you should Google it. All right, so what I like to do is, I don't like to run a jumper this way because it tends to clump up with this and creates a ugly bridge. So I like to actually scrape ground over here. And something like this. And this ensures that the ground is no longer unstable and provides a solid grounding so that the circuit can function. And what I'm going to do is I'm going to tin, since this is ground, it does require a little more heat to flow the solder. It's even hard to get solder on there. All right, that should be enough. And the trick here is to run a jumper. Let me get a piece of jumper over here behind the scenes. By the way, on that iCommands Stylo software, there's also a way to test like audio IC. So anytime you have an issue and it's a, oh, by the way, I forgot to mention, purple mode is only supported by devices A11 and older. So like iPhone 10, iPhone 8, iPhone 8 Plus is the newest models it supports. Anything else does not support, therefore you cannot use the iCommands Stylo software for solving. You have to use the old-fashioned way using standard diagnostic methods. All right, so what I'm going to do here is install this jumper like this. So hopefully you guys watched till now to know that, because I know I'm going to get people saying, oh, I have a iPhone 11, I'm like, well, it doesn't work on that. All right, so my iron's not gonna do it. So I'm gonna put the board back on the board heater so it can kind of assist with installing this jumper. All right, so I got that soldered on. Now I got to line up. Oops, I got some solder on the crystal here. Oscillator, I don't know what it is. Looks like a crystal. All right, so basically these two ground pads are solid ground. These two are the ones that are weak or disconnected. So I could technically just run these three, or these two right here, but if I run across all of them, it kind of creates a stable kind of, it holds the jumper in place also. So let's go across the whole line, and there we have it. So this is a solid ground connection. I don't need that. All right, so now let's UV mask this so it holds it in place. All right, guys, just pretend you don't see this. I'm gonna just shave this off. All right, so the goal also with the jumper is make sure it's dead center. If you're slightly off, it can bridge potentially to the pad surrounding it. And when you use UV mask, you want to put a super thin layer. So I'll put a little bit there, and then essentially in between the pads. And I think I put a little too much. So what I'm going to do is actually spread it around. As long as there's some on there, it should be more than enough to hold the jumper in place when we install a chip on top of it. And you also got to install a chip very carefully so that it doesn't bridge. It seems like a good amount. So I'm going to put my UV light on it. By the way, I do have this solution posted on the Repair Wiki. This is the site for Louis Rossmann, which he hired me to submit basically all the solutions I know for iPhones. So if you guys want to see that, go to repair.wiki and search for the iPhones, basically all the iPhone models. Well, iPhone 7 and newer, I basically wrote down everything I know about all the common issues. So, and I have this one listed there with pictures and stuff. All right, so this should be more than enough UV. And I'm just gonna scratch out over the pads and the pad itself. So I need something to solder onto. So that's why I'm scratching out the UV and leaving behind just the areas where I don't need to solder onto so that it holds the jumper in place. All right, so there you have it. Now I did forget to take note of the orientation, but I've done quite a few of these, so I kind of remember. Hopefully I'm not wrong. All right, so Qualcomm. Look at that, I have one more on this reel. By the way, I highly recommend you guys get a baseball, binder with baseball card slots so you can fill up all your small parts and ICs in there. Super easy to manage. All right, give me 1 second. Let me pull up CXW. All right, iPhone 7 Qualcomm. 7 QCOM and the Polygon version, and I actually have the board layout just like this, and you can see pin 1 is the bottom left in the same orientation I have it. So let's go ahead and get this installed. Some flux, the dot goes on the bottom left. And I'm gonna put this on my board heater just so it can assist me with the installation. And let me start off with .365 to install. I do need to line up the IC so it's virtually perfect. Alright, I would say about there. I do want to see the jumper slightly sticking out here in the bottom. That's kind of how I know when it's aligned. And I'm just going to go slow. I did put a lot of flux, so usually when I do that, I just kind of take my time with heating it up. That way some of the flux can kind of spread out and melt away or burn away before I go in too fast. Because if you put too much flux and you're trying to heat it too fast, it's going to bubble and literally bounce the chip out of alignments. So I'm just taking my time here. Also, I can use this chip here, the little crystal thing below it, as a reference point to see when the solder has melted. Because I can see the pads. And you see the solder that I accidentally put on it. How about I short it? Alright, so I'm going to turn up my temperature to 400. And I think it's soldered on, so I'm going to bump it. I would say it's soldered on. Also, let me adjust this. Alright, let's give it a second to cool down. So I'm waiting for the board to cool down, and I would say it's good. 30 seconds have passed, so let's take it off there. I'm going to use some alcohol to kind of clean it off. Also helps cool it down a little faster. All right, the board is still kind of hot. I'm actually going to put it here on the side for it to cool down, and I'll be right back. All right, I got the phone reassembled. One thing about this specific situation is if you restore a phone with a baseband problem present, what happens is the software will basically wipe that IMEI from the system, and it won't show up again until you restore it one more time. But I do want to show you guys how to check for how to use that iCommands Stylo tool so we can see if baseband is fixed now. So what I'm going to do is put it back into DFU mode. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let go of power. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, it's in DFU mode. I'm going to go through that same process. I'm only going through this just because my P10 software does not work. If you just have only the P10, then you can just use that completely. So let's go back over here, put it back in purple mode. So for example, if you only have the iRepair P10, essentially use the iRepair P10 software to put into purple mode, then close that software, then open the iCommands Stylo software, and then you can use purple mode on that other tool. You can't have both tools connected to the same tool because then, one is occupying the other one. All right, I'm into purple mode. So now close this and then reconnect. Uh-oh. I have to reopen this tool. Maybe. Yeah, it froze. Let me reopen it. There you go. So now I see the COM port, COM5, iPhone 7, connect. All right, last time I got that error. Let's try again, connect. There it goes, A1660. So let's go to RF, baseband. Does it turn on? Yes. Okay, turn it off. So let's see if we can duplicate that issue where sometimes it doesn't turn on. Essentially, that could be our kind of our baseline or something to compare against. So before it was sometimes come on, sometimes not. And right now it seems like every single time it's turning on and off. There's no errors. So this would tell me that baseband is fixed. Yeah, every single time is working. Whereas before, sometimes it would fail, sometimes not. There you go. So I don't know how many times did it, 5, 6, 7 times. Oh, it's already powered on. Let's turn it off, turn it on. I remember I had to click something yesterday. Oh yeah, check it out. Audio IC test as well. Run test. I hope it doesn't have audio IC problems. No codec problems found. Yeah, so audio IC is good. All right, turn it off. Turn it back on. All right, 100% success rate. This tells me baseband is now 100% good. So let me do this. There is a button. Yeah, so go to commands. Go here on the right. Reset device. Yes. And then unplug it. Hope it went through. Yeah, there it goes. So now I'm gonna unplug all these programmers because I don't need them anymore. And then we're gonna go to DU tools. All right, so it's still IMEI missing, but like I mentioned, it does need all the batteries low too. So yeah, you can see here IMEI and A. If you refresh, nothing. Does not read it. So let's go flash it. Retain. Well, let's restore it. So retain user data is like an update. Quick flash is like a restore. We'll just use easy flash, 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 and let's let this restore, and I'll be right back. Let me get these programmers out of the way too. All right, so it has finally restored. Click OK and go back to iDevice, and look at that, there's an IMEI here. Also, if you look at the device itself, we do see an IMEI here. It's no longer just a serial number. Although I do see it say no service. I have seen many cases where it says no service until you plug in a SIM card, take it out, and then it'll go back to no SIM. So a working phone should say no SIM when you have no SIM card inserted, which I don't. So let's go through this process. Now I don't have the Wi-Fi antennas plugged in, so I need to press here on the Wi-Fi area, antenna area, so I can pick up the Wi-Fi networks. And it should pick it up any second now. Okay, and it's not. All right, give me 1 second. Let me screw in the Wi-Fi antennas, the actual antennas, onto the housing, because that's how it works. All right, I got the antenna part screwed in. Now you can see all the Wi-Fi networks. Let me connect to my Wi-Fi. You cannot see my password. Very top secret. All right, connect. And either it'll come back with the iCloud info, or it'll just go on to the next step. Hopefully, I don't have to get the iCloud info to fully test it, but we'll see. There you go. Activated, set up later, don't use, no passcode, don't use, don't transfer, don't have Apple ID, set up later, don't use. I hate this. 3U Tools used to have a button, you could just skip all this, and Apple blocked that, so now you actually have to go through all the buttons. Don't share, appearance, display, welcome. There you go. Phone is activated, no SIM card installed. That's a big sign that everything's working. Now I don't know what carrier this is. It is a Qualcomm, so it does support CDMA and GSM. So I have T-Mobile, and let's see, let me turn off the Wi-Fi. All right, give it a few seconds, see if it picks up. I do have the cellular antennas plugged in. All right, so I'll pop out the SIM. It says no SIM now, no SIM. So this is what a working phone would do. Pop in the SIM, says no service. So it should pick up signal, hopefully. Let's see, cellular. It could be also the IMEI is blacklisted, so that could explain why it's not picking up signal. Now that would be outside of my control. Let's see. I don't get the IMEI. That's interesting. All right, if I can't figure out in the next 10 seconds, I'm just gonna call it quits. Well, modem firmware is there, so it should be working. But you can see the point of this video was also to show you that iCommands Stylo software, which lets you do a lot of diagnosing through USB on a Purple supported device. So for iPhone 7, it's free. For any other model, then you will have to pay. So hopefully you found this video helpful. You learned something new. You found a new tool that might bring you some success cases for some repairs. I know sometimes I've gotten stuck on some repairs, and if I would have had a tool like this back then when I ran into those, That would have been so useful to at least rule out, like, okay, it's not this and not that. So now I know. I'm gonna definitely use it. So hopefully I'll come across another repair where I can use this tool and record a video for you guys so you can see also another scenario where the tool can be useful. I'll be buying this software sometime soon, especially once I get a device where I'll need it and it'll be useful. So let me know down below in the comments what you think about the tool, if you've used it before, what you use it for, what did you find, how was it helpful. Let me know what else you want me to check for. If there's any other tools similar that you want me to check out, let me know as well. So thanks a lot for watching. Make sure you smash that like button if you found a lot of value in this video. Subscribe to the channel to see more video tutorials, and share this video with all your friends who do board repair because they might find this tool helpful. So thanks a lot for watching. I'll see you in the next one.